morning everyone. Myself Dr. Indrati Kumari. Today we are going to discuss about the function of governance is to maintain the speed of an engine within specified limits whenever there is a variation of load. Governors are intended to maintain the balance between the energy supply to a moving system and the external load or resistance to that system. The function of the governor and flywheel are both same, just to control the fluctuation of speed, but governor is control the fluctuation of speed with change in load by controlling the supply of the fuel to the engine. Very well. The flywheel is control the fluctuation speed by storing the energy during the power stroke and releasing the stored energy during the remaining suction, compression or exhaust stroke. Then the classification of governor. Governor is classified into categories: centrifugal governor and inertia governor. Centrifugal governor is further classified into three categories. First one is the pendulum governor, then gravity loaded governor, then spring loaded governor. The pendulum governor is the simplest governor. It is given by the watts. That's why it's called Watt's governor. But Watt's governor have the limitation of the speed at the medium or the higher speed of the engine. It becomes insensitive. To make it more usable at the medium speed, Porter and Poorley has given the gravity loaded governor, but gravity loaded governor itself has some limitations. So for more, investigators have given the spring loaded centrifugal governor. The spring loaded centrifugal governors are Hartnell governor, Hartung governor, Wilson Hartnell governor, Pickering governor, or spring controlled gravity governor. The inertia governor is Westinghouse inertia governor. This is the systematic representation of the watts or centrifugal governor. The engine shaft is connected to the bevel gear. On the another bevel gear, spindle of the governor is mounted. On the spindle, there is the two stoppers. Between two stoppers, the sleeve is mounted and the sleeve is connected to the links on the arm, and arms are connected to the axis of spindle, and the another end of arms is connected by the flywheels. On the sleeve, bell crank lever is attached to one side and another side is attached to the throttle valve. Bell crank lever is used to control the opening and closing of the throttle valve to supply the fuel in the engine. When the radius of the fly bars is more, the speed of the engine is high, then the sleeve is near to upward stopper and the fuel supply is closed. When we increase the load or the speed of the governor is reduced, then the flywheel bars will move at the lower radius and the sleeve will move towards to downward stopper, and the bell crank lever will open the throttle valve and the fuel supply will increase to the engine, and it's controlled with the change in load on the engine. Then the different configurations of the Watts governor. The The arms of the governor is connected on the spindle axis. It's a representation of the one in the figure A. Pivot may be on the spindle axis. In the figure B, pivot P may be offset from the spindle axis and the arms when produced intersect at O. And in figure C, the pivot P may be offset but the arms cross the axis O as shown in figure C. Then the terms used in governors. Height of the governor as it is the vertical distance from center of the ball to a point where axis of the arms intersect on the spindle axis. Then the equilibrium speed, it is the speed at which governor balls or arms are in complete equilibrium and the sleeve does not tend to move upward or downward. Then the mean equilibrium speed, it is a speed at the mean position of balls or the sleeves. The maximum and minimum equilibrium speed, the speed at the maximum and minimum radius of rotation of the balls without tending to move either way are known as maximum and minimum equilibrium speeds respectively. Sleeve lift, it is the vertical distance which the sleeve travels due to change in equilibrium speed. It's the distance between the top and bottom stop. Then the systematic explanation of the Watt's governor. The Watt's governor, weight of the arms, links and sleeve is negligible as compared to the weight of the ball, and weight of the ball W is acting the downward direction, that is mass into gravitational acceleration. Then the centrifugal force acting on the balls in Newton in the outward direction, and that is m omega square into r, and here omega m is the mass of the ball, omega is the angular velocity of the spindle or the ball, and r is the radius of rotation of the ball, that is a horizontal distance from center of ball to the spindle axis. It is measured in meter. And tension in the arm T. So by taking the moment about the pivot point O, centrifugal force into height of the governor is equal to weight of the governor into the radius of governor. So m omega square r is equal to mgr. Height of governor S is equal to g upon omega square. Here g is the gravitational force and omega is the angular velocity of the spindle or the engine. And angular velocity omega is equal to 2 pi n by 60 and n is the revolution per minute. So the height of the governor H is equal to gravitational force G is equal to 9.81 divided by 2 pi n by 60 whole square. So we can write it 895 divided by speed square. So height of the governor is inversely proportional to the speed of the spindle square. So, Watt's governor may only work satisfactory at relative low speeds when the speed varies from 60 to 80 rpm. When the speed of the engine is high, then the change in height is negligible and the Watt's governor becomes insensitive. And to maintain the sensitiveness of the governor at high speed. Further investigators has given the gravity loaded governor or spring loaded governor that we will discuss in. Thank you.